Hello viewers, this is Mahmoud, and in this video we are going to solve some more questions on derivatives. So the question is, find the derivative of the functions. So the first function is that is f of x equal x squared plus x minus 1 divided by x plus 3. So we are going to differentiate this function, differentiate with respect to x, because here x is the independent variable. So that's going to be d over dx of the function f of x is equal the derivative of the rational function, that is x squared plus x minus 1 divided by x plus 3. Okay, so here we are going to apply the quotient rule. So what is quotient rule? So when we apply the derivative on the quotient, let's say that is the upper divided by the lower. So the quotient rule says that you have to take the square of the lower and divide it by L squared, that is the lower square. And in the numerator, we have to skip the lower and take the derivative of the upper, that is d over dx of the upper u, and then minus, we have to skip the upper and take the derivative of the lower. Okay, that is d over dx of L. So here in this case, our upper is x squared plus x minus 1, and the lower is x plus 3. Okay, sometimes we call it the first function and the second function. Okay, the upper one is the numerator is the first function and the denominator is the second. Okay, so here the left side that can be written as f prime of x. So f prime of x is equal, we are going to apply the quotient rule. So we are going to take the square of the lower, that is x plus 3 whole square, and we divide it by that. So that is x plus 3 whole square. And now in the numerator, we will keep x plus 3 as it is and take the derivative of the upper, that is d over dx of x squared plus x and minus 1. And then minus sign, we are going to keep the numerator as it is, that is x squared plus x minus 1, and we have to take the derivative of the lower. So that is d over dx of x plus 3. Is it okay? So now here we have f prime of x is equal x plus 3 in the numerator as it is. Now we have to apply the sum rule here, the derivative of x squared plus the derivative of x and then the derivative of 1. And the derivative of x squared is going to be 2x to the power 1. We have to put down the 2 and then x to the power 2 minus 1. We use the power rule here. Okay, and the derivative of x, that is going to be 1, and the derivative of constant, that is 1. You can see here the derivative of 1 is going to be 0, and that the derivative of a constant is 0. Then minus x squared plus x minus 1 time, and we're going to apply the sum rule here as well. So the derivative of x is 1 and the derivative of 3 is 0. That will become 1 here, divided by x plus 3 whole square. Now we are going to simplify this. So in the numerator, we are going to multiply it. So f prime of x is equal Here we are going to multiply the first two factors. That would become 2x squared plus x plus 3 times 2 is 6x, and then plus 3. And here we are going to multiply this with 1, so that would become the same, and then we have to multiply the minus inside, so that is going to be minus x squared minus x and then plus 1 divided by x plus 3 whole squared. Now we are going to simplify the numerator. So here we have f prime of x is equal 2x squared and minus x squared would become x squared, and this x will cancel out with this x, so we left only with plus 6x. So plus 6x, and 3 plus 1 is going to be 4 divided by x plus 3 whole squared. Okay, so this is the final derivative of the given function. Now move to the next part, and that is part B. So here we have g of x is equal the cube root of x squared minus 3. So the equivalent form of this function is g of x is going to be equal x squared minus 3 whole power 1 upon 3. Okay, so now we are going to differentiate this function with respect to x. So that is going to be d over dx of g of x is equal d over dx. Here we have x squared minus 3 whole power 1 by 3. Okay, so now in this case the left hand side can be written as g prime of x, and on the right side we are going to apply the power rule. That would become 1 divided by 3 into x squared minus 3, and then we have to subtract 1 from the power, that is 1 by 3 minus 1, and then we are going to take the derivative of the base. This is the base, and we are going to take the derivative of the base as well. Okay, so that is going to be x squared minus 3. If it is the base is just x, so we skip them because the base, that is x, so the derivative of x is 1. Okay, so here in this case that is x squared minus 3, so we need to take the derivative. Okay, because it is not obvious that the derivative of this thing would be 1. But if there is a x, so no need to take the derivative because that is obvious, the derivative of x is 1. Okay, so g prime of x is equal 1 upon 3 x squared minus 3, and the power would become 1 upon 3 minus 1 is going to be negative 2 upon 3. Okay, and now here we are going to use the sum rule as well. So the derivative will apply with x squared and then with 3. So we know that the derivative of x squared is 2 times x, and the derivative of 3 is going to be 0 because it's a constant. Now here we have g prime of x equal, this can be written as 2 multiply x divided by 3 times x squared minus 3 whole power 2 divided by 3. Okay, so more precisely it can also written as g prime of x is equal 2 times x upon 3 into cube root of x squared minus 3 squared. Okay, so this is the derivative of the g of x. Now move to the next problem, that is problem C. That is, the function is, that is h of x, and that is going to be square root of x times x squared plus 1. So again, we are going to differentiate this function with respect to x. So that is going to be d over dx of h of x equal the derivative of the function, that is x squared. So that can be written as x to the power 1 by 2 times x squared plus 1. So now here we have the product of two functions. You can see here, this is my first function and this is the second function. So here we are going to use the product rule. Okay, so you can see when we are going to find the derivative of the products of two function, that is first function times second function. So how can we apply the derivative? So we will keep the first function as it is, and we are going to take the derivative of the second function. Okay, then plus we will keep the second function as it is, and we are going to take the derivative of the first function. Okay, this is what we call the product rule. Okay, so here we are going to use the product rule. So on the left side, that can be written as h prime of x is equal, and on the right side, so we will keep x to the power 1 by 2 as it is, and we are going to take the derivative of the second function, and that is x squared plus 1. And then plus we will keep the second function as it is, that is x squared plus 1, and we will take the derivative of the second function of the first function, that is x to the power 1 by 2. Okay, now here we have h prime of x is equal x to the power 1 by 2, and now here we are going to apply the sum rule, the derivative of the first term plus the derivative of the second. So the derivative of the first term is going to be 2x, and the derivative of 1 would become 0. And then plus here we have x squared plus 1, and now we will take the derivative of x to the power 1 by 2. So here we are going to use the power rule, that is 1 divided by 2, and then x to the power 1 by 2 minus 1. Okay, so h prime of x is equal, so here we have, that is going to be 2 times x into square root of x, plus here it can be written as x squared plus 1 and 1 by 2, x to the power negative 1 by 2. Okay, more precisely it can be written as that is h prime of x is equal 2 times x into square root of x, plus this can be written as x squared plus 1 divided by 2 times square root of x. So this is the derivative of the function h of x. Is it okay?